our system reliability and reduce our maintenance costs. So the key is how to achieve this goal, how to use our latest technologies to achieve the ultimate goal. So data is the key because data means information. It describes the building operation. So if we can obtain data from different systems effectively, we can good for our AI learning. So let me give an example of BMS integration. Lots of speakers mentioned the naming standardization and semantic model. I would like to highlight the data resolution. In the past, we log our BMS data, say in 10 minutes interval or even 5 minutes, but how we can further improve our logging from 10 minutes interval to 15 seconds. That means we have the high resolution data. Just like we have the high resolution picture, we know the details, and this will be particularly useful for our data cleansing and also the machine learning. And why BACnet? I think, as I said, quite a lot of speakers mentioned the reasons, so I don't want to repeat once more. So here is the typical BMS network. If our controller and device is BACnet ready, that means get the PTL certification, we can simply connect the another server to this BMS network to obtain the data. We can create the BACnet point for the third-party server. So this is quite easy to obtain the data if these devices and the controllers are BACnet ready. So BACnet standardize the object type. So for the analog, binary, alarm, and schedule, that means we can get the points, get the alarm, acknowledge the alarm, get the schedule, and modify the schedule for the BACnet. So let's say for the analog input, these are the properties of these objects. So all are standardized. So we don't need the API documentation about these properties. We know it before for the integration. So we can, for the BACnet, we can easily obtain the data. Data means the value, unit, and even the status of the point. So this is quite simple. So I would like to mention about the data resolution impact. For example, we have 10,000 BMS points. And in the past, maybe we log our data in 10 minutes interval. So after 10 minutes, we have 10,000 data. But what if, and 1 hour later, we have around 60,000 data. For 1 day, it will around 1.4 million data. So if we improve our logging to 15 seconds, the data size will be 40 times more. So for 1 day, it will around 60 billion data per day. It's quite a lot. But how we can log the data in that interval? Before that, I would like to mention the importance of the high accuracy data. You can see that this is the 50-second log data. So you can know that when we switch on the chillers, the cooling time required for our chill water to become the set point, we can calculate the cooling time. We can know which data is the transient state data, which data is the steady state. So this is particularly useful for fault detection. So luckily, BACnet supports COV, change of value. That means we can have the data in high frequency way. Let me give some example. For the on-off status, for 1 day, maybe chillers only on 1 time and off 1 time. For when we use the change of value, that means for the whole day, we only have 2 data to represent the whole day. For the temperature, if the COV is 0.2 degrees Celsius, that means the data only transmit when the change of value more than the threshold value. So we can, by using the COV, we can significantly reduce the data size, but we can still have the 15-second data log. So for the COV, we can minimize the network traffic and ensure all the changes are captured. This is particularly important when we compare to the polling. If we use the polling method for the 15-second data log, it will around, as I said, for the 1 day, it will around 60 million data. But for using the COV, even we have the 50-second interval, the data size is significantly reduced because some data will not change from time to time. Let's say the status, it only may be changed a few times a day. For the temperature, if the COV is set around 0.2 degrees Celsius, most of the data will not change that frequency. So the data size can be significantly reduced. That is how we can obtain the high frequency data. For the naming of the BMS form, in fact, we have different standards. We use this standard to name our BMS form at our ATAL tower, start from the building code, floor code, and then the equipment code, etc. When we name our BMS form in this way, we can, the DeepSeek can understand the data meaning completely. That means for the RAT, the DeepSeek can understand this is the return AFM. So by the standardization of the naming of BMS form, it enables natural language processing and making the data machine understandable. So when we have the semantic model, it will tell the relationship between the data and the sensors and also the assets. So this is the ATAL tower. We build a semantic model. We can see that in the zone 6, we have these VAV boxes. This VAV box will serve the cooling to this zone, and this VAV is connected to this AHU. So we can know the whole relationship. When we have this relationship, we can ask our DeepSeek to talk about the relationship of this building. So something like, okay, this AHU is served how many boxes and the zone containing which rooms, etc. So the DeepSeek can fully understand the semantic meaning. So when we have the standardized naming and also the semantic model, we can have some fancy application like my boss, Dave. He asked, he feels cold in his room. Now we can use the AI chatbot to answer this question. Because of the semantic model, he knows that Dave, my boss, is in this room, and this room have this VV boss, and know the temperature of this room and also the set point, the air flow rate, so he can diagnose the whole process through the AI. That is the one application, and this is applied in our ATAL tower. For the modern, as I said, using the BACnet, we obtain the raw data. But of course, data need to be processed, like to do the data cleansing, etc. So, for example, we need to do the data missing tracking, whether there's any missing data, whether there's any data outlier, and also we need to do the consistent tracking, like when we turn on the chillers, whether the power is go up as well. If the data is not consistent, then there's something wrong with the measurements. So we need to validate against the other data, like for the office building, we can validate the data between floors to see whether these data are consistent and also the integrity of the data. So that means for when we got the raw data, we need to do a lot of processing. So in the traditional database, it will not facilitate this process. So we need the modern data lake. And why modern data lake? Because it decouples the storage and compute. That means we do not predefine the schema at the beginning. We just put our raw data in the data lake and store in the storage format instead of the relational database or non-relational database. We just store the data in an object format. And once we query, we can read the schema on demand. That means we do not need to predefine the schema. That is the flexibility of the data lake. And so it can enable us to do the missing data analysis and other data quality checking process. So when we have the data, of course, we can let the AI to do the energy optimization. Why AI is better? It's simply because it can help us to find out the optimum control setting based on particular cooling mode and weather condition. What does it mean, the optimum control setting? That means that setting will minimize the energy use of the whole chiller plant or whole HVAC system. The key, because AI has the prediction ability, that means you can ask the AI, what if we control in this way? Say, operate 2 chillers, 3 cooling towers at 25 Hz. The AI can answer, okay, it will consume 100 kilowatts. So if we ask again and again, definitely under the particular loading and the weather condition, there should be the optimum control setting that will minimize the whole energy use. So the key is the modeling. Of course, when you need to do a better model, we need to do a data cleansing. So if we have a high frequency data, that means we have a better ability to model the plant accuracy. Once we have the accurate model, that means we can ask, okay, if we control like this, what is the energy use? So by this way, we can search the optimum point based on different combinations. So, but in reality, some data will be missing, not because of the sensor issue, just some operation never be operated. So there is some, for example, for these chillers, we don't have the light slow operation. So how can machine can learn this performance? So we developed a new method called the physics-guided machine learning. It combines physics and machine learning for the modeling. Because this is the HVAC system, it must obey the thermodynamics. So we combine this physics law into our machine learning process and making, even with no data or limited data, we still have a good modeling performance. With that, every equipment, chillers, pump, and cooling tower has specific machine learning model. With this model, just like we can ask the AI, if we control like this, what is the energy use? With this ability, it can automatically search the optimum control setting for the energy efficiency. And that setting can pass back to the BMS system by BACnet to control the plant. That is how we operate, and this has been implemented at our ATAL cloud. So for the condition-based maintenance, in the past, we will maintain our system at a fixed schedule, say quarterly or annually. But with data, we can maintain our system when it's needed. That means when the condition deviates the baseline performance, we do the maintenance. But how to define the condition? We can have these 3 aspects to define it. First is the energy performance. Energy performance means under the same condition should be the same energy use if there's no deterioration. that must be true. If under the same condition, that should be the same energy use, no matter what. If we find that the energy use is consumed more, that means it's deteriorated under the same condition, we need to do the maintenance. Another aspect is the control stability. Because the HVAC system use the PID control, that means for the chillers, it will provide the stable chill water supply temp. For the AHU, it provides the stable supply air temp. It removes the PID control loop. If the system unable to provide the set point, that means something wrong with the system. With the high frequency data, we can diagnose the fault related to the PID. So that is the power of the high frequency data. Another aspect is the thermal comfort. Because for the HVAC system, the main purpose is to provide the comfortable indoor environment. If it's unable to provide the room temperature set point, that means something wrong with the system. So that is how we define the condition. If any of the aspects is deviate the intended purpose, we need to do the maintenance. So as I said, we have the data, we can do the machine learning. That means it can capture the characteristic of the performance. Then we can compare it by monthly or compare it by annually to see whether there is a deviation. This comparison is apple-to-apple comparison. So it is so for this example, we can see that for the light source condition, it deviates the baseline performance. That means something wrong with this asset, and we need to do the maintenance. If the performance is the same as the baseline performance, we can, in theory, we do not need to do the maintenance because it can provide the same energy use under the same condition. So that's the end of my presentation. I would like to give some takeaway. Unified data is the power, and lots of the speakers mentioned the semantic model, naming standardization. I would like to highlight the data web solution. If we have the ability to collect the high frequency data, of course we try to collect it, because the more data we have, the better data cleansing we can do, and also good for machine learning. And luckily, BACnet enable us to do so. And another aspect I would like to highlight is the modern data lake. Because we have to do, when we get the raw data, we need to do a lot of processing, like the data cleansing, data quality checking, etc. So the modern data lake supports this application. This is flexible. It is not need to predefine the schema. It can calculate in a parallel way. That means you can use the distributed computing to do the processing. And also once we have the processed data, we can use it for the AI optimization and also the condition-based maintenance. And that serves an ultimate goal: save energy, reduce the maintenance cost. So that's the end of my presentation. Thank you.
Excellent presentation. Please be seated. A reminder for all online participants who would have questions for Dr. Lee, please comment in the chat box and our technical team will consolidate the questions for the Q&A session. Time has passed so quickly. Now we are excited to move on to the last topic of today's conference. Before inviting our final speaker, Mr. Herman Chow, to join the stage, let me introduce his biography. Mr. Herman Chow is a distinguished leader in the testing industry, currently serving as the head of testing team of Smart City Division at the Hong Kong Productivity Council. Accomplished director-level professional with 15 years steering growth and compliance in testing, inspection, and certification (TIC) across Fortune 500 firms and public sector initiatives. Expertise spans from softline, hardline, toys, automotive, 5G, wireless, and smart building systems, BACnet, hiring award-winning technologies such as the Edison Award 2024 and navigating complex regulatory landscapes. Bridging traditional sectors such as textile and toys with emerging technologies such as EVs, automotive, autonomous driving, smart cities, while fostering cross-functional teams and global client partnerships such as Walmart, Toyota, and Huawei. Currently driving Hong Kong's smart infrastructure evolution via BACnet certification and AI-powered inspection tools, following a decade of leadership at UL and the Bureau Veritas, scaling testing services and in EU and ASEAN markets. Now, may I invite Mr. Herman Chow to join on stage to share his topic of development of BACnet, verification tool during TNC and handover in Hong Kong. Mr. Chow, please.
Thank you very much for your kind introduction. Yes, I'm from the testing industry. We call it myself a testing guy. So that is testing, inspection, and certification field. So why am I joining you guys building industry? This is amazing. 3 years ago, that Taylor and Cecil approached me that we have devices that will need BTL certification, and they are looking for someone who has experience in testing to carry out this project. That project is still in progress because we on and off today in the morning section you hear about Mr. Andy McMillan. We know that the guys I'm dealing with is a little bit old-fashioned, right? They are all BACnet, complicated Herman. BACnet is so there's something I'm working. But the second thing that I cross path myself with the building is on the pain point that recently we addressed. That I listened to the industry. It's difficult for a property owner or the facility manager to understand what is being built inside the BMS. That is when I approach a contractor, maintenance contractor, or whatever the BMN installed into my building, I don't know what are being installed. Say, come on, it's just like a checklist. Oh, we take checklist, but what is being installed, I don't know. I don't have a clue on that unless we have something that can verify. Hey, send a signal, giving back. So this is how I cross path with the building industry, and that's triggered me that we need to invent something that can trigger it. So okay, so that's me, and that's why I'm here today, and then that's HABC I'm working for, and I'm from the Smart City division, and under SJ protocol we cannot do any advertisement, so I skip here, but the fact is that HABC is right opposite here. So that the building in Taxi Road Avenue 78. So right opposite here. Then, but under SJ protocol, I can promote myself. So Herman, my name is Herman, and I'm heading the Smart City division on field initiative that is for the energy and healthcare and the building solutions. So there are one sentence here. In the field of quality, I'm an auditor from accredited by the Australia and the China, the CNAS, which means I am able to drink a little bit of alcohol. So, and my duty, apart from doing just testing, our role is also expanded to do some R&D services. But fundamentally, I am from the testing field. So some of the projects that I'm doing is also for testing. One of the iconic one is more on, it's like this one. Okay. Yeah, that's the we call it as Inspect Spider. Ms. MC has just mentioned it. Fundamentally, it is a robotic system that can climb up into a very high mast, and then that. But the principle, but the major function of it is not just climbing up. Is for checking of the rusting, any resolution, and then we develop a lot of golden sample, whether it is rusting to the grade 5 or grade 4, and then we use the AI technology to spotlight it, and then whether it's maintenance, and then we will do it offline, and then to increase the improve the efficiency and reduce a lot of the downtime to do the checking. So that is what our R&D is doing, and that is my testing services. So in HAPC, we have a lot of ISO 17025, that is hottest accredited laboratory in HAPC. And then we do a lot of testing like this MCF mentioned, software testing, voice testing, chemical testing, electromagnetic activities testing, reliability testing, and what I'm working is, which I hope I can bring good news like the end of year to all you that the BACnet testing laboratory can get the pass mark from the BTL. This is what we hope for. So, but in HAPC.